You now have Mongoose models set up for both users and tasks. You also know how to use those models to create new users and tasks, storing them in the database. Now, we're going to have plenty more to say about customizing Mongoose and setting up relationships between things like users and tasks. But for the moment, we have enough Mongoose knowledge to actually start building out the HTTP endpoints necessary for the task application. Before we actually dive into writing code for these new HTTP endpoints, what I want to do is go through a quick presentation, which is going to give us a brief overview of how we'll be structuring our HTTP endpoints for the task API, and we're also going to get a sneak peek into what exactly makes up an HTTP request. Let's jump right into that. In this presentation, we're going to cover a few different topics all directly related to the REST API, but to get started, I want to define what exactly a REST API is. Now let's break this acronym up into its component pieces. Right here, that stands for the following. So REST stands for Representational State Transfer, and API stands for Application Programming Interface. Now you'll see this shortened to REST API or RESTful API. Now to get started, I want to go ahead and define what exactly an application programming interface is. An API is nothing more than a set of tools that allow you to build software applications. It is a very broad term. So we could say that Node provides us with APIs. It does. Things like FS enable us to build the applications we're trying to build. And we could also say that our NPM modules like Express provides us with APIs, which it does. Express provides us with a set of tools that allow us to build software applications. Now, in this case, the REST API we're creating is also going to provide a set of tools allowing others to build out their software. Now let's move on to the harder thing to define, representational state transfer. The REST API allows clients, such as a web application, to access and manipulate resources using a set of predefined operations. So what's a resource? Well, something like a user or a task. And what's a predefined operation? Well, a predefined operation for users and tasks could be something like the ability to create a new task or to mark a task as complete, or to do something a bit more advanced like upload a profile picture for your user account. So these predefined operations are going to allow a client like a web app to go through the process of creating a front end for a task manager. Now, there are three words up above representational state transfer. First up, we have representational. With a REST API, we are getting and working with representations of our data. So the data is stored in the database, but using the REST API, I can still fetch data, I can manipulate data, and I can perform all of those basic CRUD operations. So we're working with representations of our users and tasks. Now, when it comes to state transfer, a REST API, the server, it's stateless. The state has been transferred from the server to the client. So each request from the client, such as a request from a web application, contains everything needed for the server to actually process that request. This includes the operation they're trying to perform, all of the data the operation actually needs in order to work, and it also includes things like authentication, making sure that the user who's trying to perform the operation is actually able to do so. Now, all of this will make way more sense once we actually put it into practice. In practice, the requests are going to be made via HTTP requests. So this is how a client like a web app is going to be able to perform those predefined operations. So right here, we have a client and a server, and the client is going to have a requirement. Like, I need task data to show on this page, so it's going to make an HTTP request to a specific URL on this server. Here I am using the getHTTP method to make a request to /tasks/A7EAA, where this is the ID of the task I'm trying to fetch. Now in this case, I've shortened the object ID for this presentation. As we've seen before, object IDs are a bit longer than just 5 characters. So we make the request to the server. The server is going to be able to go through the process of fulfilling it. It's going to find the data in the database, in this case, looking for the task by ID, and it will send it back as part of the HTTP response. So right here, I have a status code, in this case 200, indicating that everything went well, and I have the JSON response with the data that was requested. Now, you most likely know about other status codes like 404 for page not found, and we'll explore the complete list of status codes available as we start to build out our API. Now, the server sends the data to the client, and the client can actually render things. With the REST API, though, we'll be using more than just GET requests to ask for data. We're also going to be creating data, deleting data, and updating data. So with that, we still have a client and a server, and we're still making an HTTP request after some need needs to be fulfilled. Something like, I'm Andrew, and I need to create a to-do. So here I'm authenticating as myself, and I'm trying to perform one of our predefined operations. So right here, I'm going to fire the request off. Now this time, we're no longer using the get HTTP method, we're using a different method, post, which is used for creating data. So here, post /tasks is going to allow us to create a new task, and we're also sending along JSON with the request. We're sending along things like the description, which we made required in the last video, and the completed status, which is optional. Now, when the server gets that, it's going to authenticate, making sure that we do indeed have an account. Then it's going to create that to-do associated with us. And once the task has been created, we'll get the response back. Here we are seeing a different HTTP status code 201, which signifies that a resource was created. And we're also getting a JSON response, the new task that has been created. The client will eventually get the response, and it'll be able to use it to signify to the user in the user interface that things went well and that the task was created. Now we'll learn more about the various HTTP methods and status codes available to us. In the next slide, what I'd like to do is go ahead and talk about the predefined operations we'll typically have for our resources. And in this case, we'll talk about some of the predefined operations we're going to have for the task resource. In order for anyone to be able to do anything meaningful with our API, we need to expose the necessary set of predefined operations for things like the CRUD operations, create, read, update, and delete. So let's start with C for create. Right here, I have the following, allowing you to create a new task. Now, every single REST API operation is defined with two pieces of data, the HTTP method and the path. So in this case, we are using the HTTP post method to /tasks, and this is what we set up for creating a resource. Now imagine the resource changed. Imagine I'm working with an e-commerce website, and I want the ability to create a new product that I'm selling. For that, I would use the post HTTP method with /products. Where the thing that comes after the / is the pluralized version of the resource. So tasks, or products, or orders, or anything else you might be working with. After C for create, we move on to R for read. And when it comes to structuring your REST API, you'll typically have two read operations, one to fetch multiple of a given resource, and one to fetch an individual item, like an individual task. Let's go ahead and start with the pluralized example. So right here, we have the operation for getting all of our tasks. It is indeed a read operation, and we're using a familiar HTTP method, the get method. So we have post for posting new data to the server, and we have get for getting existing data. Now you'll notice that the path is exactly the same, /tasks. This is the setup we'll use when we're trying to get all of a given resource. To bring us back to that products example, it would be /products to fetch all of the products. Now there is that second read operation, the ability to fetch an individual resource, and for that we have something like the following. It's still a read operation, and we're still using the HTTP get method. Right here though, the URL has changed. It's now /tasks /:ID. Now, :ID is a placeholder. This will get replaced with some value, and in the case of this particular path, it'll get replaced with the ID of the task we're trying to fetch. So we're going to see /tasks when we're working with multiple of a resource, and then /tasks /ID when we're targeting an individual item. So next up on our list of CRUD operations is U for update. Right here we have that. For update, we use a third HTTP method, patch, which allows us to patch up our existing data. In this case, we could do something like make a task complete when it was previously incomplete. Now, in this case, we're working with an individual task, so we see the same URL setup as we had up above. It is only the HTTP method that has changed, and we'll learn how to actually manipulate these methods as we start to build out the REST API. Next up, after update, we have D for delete. In this case, we use the delete HTTP method followed by the same URL structure we saw with the last two. Because in the case of delete, we are deleting an individual task by its ID. So these are the basic URL structures we'll see. We have /resource, where the resource name is pluralized. Then we have /pluralized resource /the ID when we're trying to manipulate an individual resource. This is the common REST API structure, and this is what we're going to work to build out in this section. Now, before we go, there's one more thing I want to talk about. As we put all of this into practice, we're going to be sending hundreds of HTTP requests back and forth between the client and the server, and it's a good idea to know what exactly makes up an HTTP request. What exactly is getting sent back and forth between the client and the server? And the answer is that it's just some text. So the structure of an HTTP request is text-based. Here I have an example request, and there are three main pieces. First up, line number 1, this is known as the request line. This contains the HTTP method being used, the path, and the HTTP protocol. In this case, we know that the combination of post with /tasks means that we're trying to create a new task resource. Now, after that request line, we have as many request headers as we need. Here we have 3: accept, connection, and authorization. Headers are nothing more than key value pairs, which allow you to attach meta information to the request. So here we are using accept to say that we're expecting JSON data back, which is what we'll get. We're using connection to say that we're likely to make other requests shortly, so let's go ahead and keep this connection open to keep things fast. And we're also setting authorization to set up authentication. Now in this case, I have trimmed that value as it's quite long, but we'll learn how to set that up later. Now we can have as many headers as we need. In this case, we have 3. After we're done with the headers, we have an empty line followed by the request body. So when we post data to /tasks, we have to provide that data, and we provide it as JSON right inside of the request body. Down below, I have the following where I set up description, giving it the value of order new drill bits. Now you'll notice that I'm not providing a completed value because I can just fall back to the default value, which is false, and that's exactly what I want. Now, once the server gets this request, it's going to be able to parse it, and Express does great work for us by giving us access to all of this in a much easier interface, and it sends back a response which looks quite similar to the request. Here, we have the status line, which contains the protocol, followed by the status code, followed by a text representation of the status code. So in this case, our protocols match up. The status code is 201, and 201 stands for created, much like 404 stands for not found. And once again, you'll see a complete list of the status codes available shortly. Next up, we have our response headers. So down below, I have 3 headers: date, server, and content type. Date just signifies the time when all of this happened. The server would be Express, and the content type is metadata about what's below. In this case, we're saying that it's JSON. Next up, we do indeed have an empty line, followed by the response body, which in this case is the complete task, with the ID and completed values set up, and right here we have the description we provided. So we'll send body JSON in the request when we're trying to pass things over to the server, and we will get body JSON in the response for almost everything we do. So this is the basics of what makes up a request and a response. Now let's go ahead and start to put all of this into practice. As far as visualization videos go, I know this one was a bit long, but it's important to understand everything that makes up an HTTP request, as well as the basic structure for the HTTP REST API resources, which is what we explored in that last slide. All right, that's it for this one. Let's jump into the next one.